Today we're going to be going over some of the commonly missed questions on the SAT 3. So let's start with this one. It says, at how many points do the graphs of the given equations intersect in the xy plane? So we can see that this problem is going to be dealing with systems of linear equations. So if you take a look at these two equations, we can see that they have the same slope, which is 2, but different y-intercepts. So whenever you have two equations with the same slope but different y-intercepts, those are parallel lines and they're actually never going to intersect. If you graph two parallel lines, let's say one of them starts here, but the other one starts down here, so it has a smaller y-intercept, but the same slope, you can see that they're increasing at the same rate. But since they're parallel, they're actually never going to reach each other. They're never going to intersect, so there's no solution. And another way you can confirm that is if you're ever given a system of equations, if you want to find the solutions, or if you want to find the number of solutions, you can just graph them. So if we graph these two, we have 2x plus 10 and 2x minus 1. We can also confirm by graphing that these two are parallel and they're never going to intersect. So the answer for this one is no solution, or 0 solutions. So if you got this one wrong, then you should review parallel lines and systems of linear equations. Let's look at the next one. It says a given equation relates variables x and y for what value of x does the value of y reach its minimum. So we can see that this is a quadratic equation. It's the equation of a parabola, and whenever you have an upward opening parabola like this, the minimum is going to be at its vertex. So all we need to do to find the minimum x value and y value for this one is just graph it and see where its vertex is. So this is x squared minus 14x plus 22. So you can see that this is a parabola and the minimum is at its vertex. The x value for the vertex is 7 and the y value for the vertex or the minimum is negative 27. They're asking for the x value, so then that's going to be x equals 7. This question says the function h is defined by h of x is equal to 4x plus 28. The graph of y equals h of x in the xy plane has an x-intercept at a, 0 and y-intercept at 0, b, where a and b are constants. What is the value of a plus b? So to find the value of a plus b, we just need to find the x and y-intercepts. Remember that the x-intercept is the x value when y is equal to 0, and the y-intercept is the y value when x is equal to 0. So if we take h of x equals 4x plus 28, we can start with the x-intercept. So we just plug in y equals 0 or h of x equals 0. So 0 equals 4x plus 28. Solve for x. X equals negative 7. So when they say that the x-intercept is a, 0, this is at negative 7, 0. The x-intercept is at negative 7, 0. So then our a value is just negative 7. Now let's find the y-intercept. So we're going to take the same equation, except the y-intercept is the y value when x is equal to 0. So I'm going to plug in x equals 0, and I get h of 0 is equal to 4 times 0 plus 28, or just 0 plus 28, or 28. So then the y-intercept is 0, 28, 0 for x, 28 for y. So then 0, b is 0, 28, and b is going to be 28. So we can see that a is negative 7, b is 28. Negative 7 plus 28 is going to be 21. So they were asking us for a plus b, that's what that's going to be. Let's look at the next one. It says a scientist initially measures 12,000 bacteria in a growth medium. 4 hours later, the scientist measures 24,000 bacteria. Assuming exponential growth, the formula P is equal to C times to the power of RT gives the number of bacteria in the growth medium where R and C are constants, and P is the number of bacteria T hours after the initial measurement. What is the value of R? So this question is dealing with exponential functions. So if you miss this, then you should review exponential functions. We know that exponential functions, the standard form is y is equal to a times b to the power of x, where a is the initial amount and b is the growth factor. So if we apply that to this situation, we can see that the formula they give us is P is equal to C times 2 to the power of RT. So 2 is going to be our growth factor, and they tell us that the initial amount of bacteria is 12,000, right? So we can actually replace C with 12,000 because that's the initial amount. They also tell us that after 4 hours, the scientist measures 24,000 bacteria. So why don't we plug in 4 and 24,000? So P remembers the number of bacteria after some number of hours, so we're going to plug in 24,000 bacteria, and he observed that after 4 hours. So I'm going to plug in 4 for T. We don't know what R is. That's what they want us to solve for. So we can see that we have 24,000 is equal to 12,000 times 2 to the power of 4R. So think about what exponent would this need to be for this equation to be true. 12,000 times 2 to the power of what? If we had 2 to the power of 2, let's say, that would be 4. Would 12,000 times 4 equals 24,000? No, that wouldn't work. The only exponent that would work is if this was 1, which means that you have 2 to the power of 1, which is just 2, right? Because 12,000 times 2 is equal to 24,000. So now we know that this exponent, 4R, needs to be 1. 4R equals 1, and if 4R equals 1, then divide both sides by 4, R is equal to 1/4. And you can see that if you replace this exponent with 1, then it works. Because 2 to the power of 1 is 2, and 2 times 12,000 is 24,000. So then R must be 1/4. Let's look at the next one. This question is dealing with rational expressions, so if you missed that, then you should review rational expressions. For this one, we're going to subtract these two rational expressions, and first to do that, we need to find the common factor, or the common denominator. So the easiest common denominator in this case is just going to be multiplying the two denominators. So let me rewrite this over here. We have 4 over 4x minus 5 minus 1 over x plus 1. So my common denominator that I'm going to use is 4x minus 5 times x plus 1. So we can see that for this first fraction, it already has the 4x minus 5 in its denominator, but it's missing this x plus 1. So I'm going to multiply the first fraction by x plus 1 on the numerator and denominator. So I'm going to have 4 over 4x plus 5, and then I'm going to multiply times x plus 1 on the numerator and denominator. And then for the second fraction, we can see that it already has the x plus 1 in the denominator, but it's missing this 4x minus 5. So I'm going to multiply this second fraction by 4x minus 5 on the numerator and denominator, or 4x plus 5. Okay, so now this first fraction here is going to become 4 times x plus 1 over 4x plus 5 x plus 1. Oh, sorry, this should be, I don't know why I've been saying 4x plus 5. It should be 4x minus 5. 4x minus 5. Sorry. Okay, so yeah, this first fraction becomes this, and the second fraction is going to become 4x minus 5 over x plus 1 times 4x minus 5. Okay, so now that both of these fractions have a common denominator, I can combine them. I'm going to multiply out this 4 times x plus 1, so then if I distribute that, it becomes 4x plus 4. And then when I'm subtracting these, I'm gonna apply this negative sign to this entire expression, this entire numerator. So I'm gonna write this as minus 4x minus 5. So this negative sign applies to both of these terms. And then all this is going to be divided by x plus 1 times 4x minus 5. And now all I need to do is simplify the numerator. So we can see that on the numerator, if I were to distribute this negative sign, I get 4x plus 4 minus 4x plus 5. And we can see that these 4x and negative 4x cancel out, and the 4 and 5, when you add them, become a 9. So my new numerator is just going to be 9 over, that whole denominator, x plus 1 times 4x minus 5. So then that's going to be my answer. And if I look at my answer choices, that's going to be D. Okay, this next question says, a company opens an account with an initial balance of $36,100. The account earns interest and no additional deposits or withdrawals are made. The account balance is given by an exponential function a, where a of t is the account balance in dollars t years after the account is opened. The account balance after 13 years is $68,071.93. Which equation could define a? So this is another question dealing with exponential equations. Remember that the general form is y equals a times b to the power of x, where a is the initial amount, b is the growth factor, and then x is the time periods. So in this case, we actually don't need to know everything. First, it's enough to know that the initial amount is 36,000 and it's growing, right? Because we can see that after 13 years, it becomes 68,000. So it's clearly growing, which means that our growth factor needs to be greater than 1. If our growth factor is less than 1, right? Let's say your initial amount is 36 and your growth factor that you multiply it by is 0.1. This is going to become like 3.6, right? That's going to become less. So your growth factor needs to be greater than 1. So maybe you have 36 times 1.5. This becomes, let's see, like 54, right? So if you want there to be exponential growth, then you need to have a growth factor greater than 1, not less than 1. So if we look at our answer choices, we can immediately knock out B and C, because the initial amount is not 36,100, right? They told us that the initial amount is 36,100, so B and C are automatically incorrect. And now we can also eliminate D, because notice how the growth factor is less than 1, right? If you multiply 36,000 by 0.05, that's going to become way less. That's exponential decay. But we want exponential growth, remember, because they said that after 13 years, it becomes $68,000. So then the only answer choice that works is A. Notice how we have the correct initial amount, and also the growth factor is greater than 1, so we're actually growing instead of decaying. Okay, this next question says, the function W models the volume of liquid in millimeters in a container t seconds after it begins draining from a hole at the bottom. According to the model, what is the predicted volume in millimeters draining from the container each second? So what it's asking for is the rate of change of the volume of this container. So this equation is written in the form y is equal to mx plus b. I'm actually going to rewrite this. So instead of having 300 minus 4t, I'm going to write this as negative 4t plus 300. And this makes it more clear that negative 4 is my slope or rate of change. So I'm decreasing by 4 each second. So the volume of this container is decreasing by 4 each second, which means that my rate of change is 4. And it's asking for the amount draining out each second, which is just going to be 4. Alright, this question says, a window repair specialist charges $220 for the first 2 hours of a repair, plus an hourly rate for each additional hour. The total cost for 5 hours of repair is $400, which function f gives the total cost in dollars for x hours of repair, where x is greater than or equal to 2. So we can see that if we were to model this, if we make a drawing to model this, the first 2 hours are going to cost, let me draw those hours longer. The first 2 hours cost $220, and after that, you have some sort of hourly rate that we don't know. But we do know that 5 hours costs $400. So if we want to know what is the total amount for the 3 hours after the first 2 hours, that's just going to be 400 minus 220, which is 180. So we know that the next 3 hours after the initial 2 hours are going to cost $180. And if the next 3 hours after the first 2 hours cost $180, then the hourly rate that they're referring to is just 180 over 3, which is $60 per hour. So each of these, after the first 2 hours, costs $60 per hour. So now if we go back to this problem, it's not asking for that. It's asking for the total cost for X hours of repair where X is greater than or equal to 2. So this is asking for, if we start from hour 2 or greater, what is the cost? How can we model the cost? Well, we know that the slope is going to be $60, so we can immediately eliminate C and D. And now if we take a look at these two answer choices, if we just plug in values for these two equations, we can determine which one is correct. So we know that the total cost for 5 hours of repair is $400. So if I plug in 5 hours into this first equation, I get 60 times 5 plus 200, which is 300 plus 200, or 500. Let's see. Well, we know that's not correct. Let's go to this next one. So 60 times 5, or sorry, I got this one wrong. This shouldn't be 200, it should be 100. So 60 times 5 plus 100, which is 300 plus 100, which is 400. So then this should be correct. A is correct. If we try B, we get 60 times 5 plus 220, which is 300 plus 220, or 520, which is not correct. We know that the total cost for 5 hours should be $400. So then A should be our correct answer. Let's take a look at number 20. It says, in the given equation, k is an integer constant. If the equation has no real solution, what is the least possible value of k? So this question is dealing with quadratic equations and the discriminant. So if you miss this, then you should review those topics. So why don't we take a look at this, and I'm going to expand out this equation. We have x times kx minus 56 equals negative 16. So I'm going to multiply this x into the parentheses, and I get kx squared minus 56x equals negative 16. I'm going to add 16 to both sides, and I get kx squared minus 56x plus 16 equals 0. So now I have my quadratic equation, and it's saying that if the equation has no real solution, what is the least possible value of k? So if you remember, this is a quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac over 2a. And this part inside the square root is the discriminant, b squared minus 4ac. Now, if the discriminant is greater than 0, then you're going to have two real solutions. If the discriminant is equal to 0, you're going to have one real solution. And if the discriminant is less than 0, you're going to have no real solutions. And you're actually going to have two imaginary. Now it's asking if this equation has no solution. So that's going to be when the discriminant is less than 0. So why don't we start off by finding the discriminant in this case? We know that this is written in standard form, ax squared plus bx plus c. So if we want the discriminant, which is b squared minus 4ac, my b value is negative 56. So I'm going to take negative 56 squared minus 4 times a, and we can see that the a value is just the x squared coefficient. So in this case, the a value is k, and k is just some constant. We don't know what it is, but it's a constant number. And then the c value is going to be 16. So minus 4 times k times 16. This is the discriminant, b squared minus 4ac. Now we know that if we want there to be no real solution, then this should be less than 0. So now all we need to do is solve this inequality for the least possible value of k. So let's start with negative 56 squared. If I plug that into my calculator, that's going to give me 3136. Let me double check that. Yeah, 3136 minus 4 times k times 16, or minus 64k, is less than 0. Now if I add 64k to both sides, I get 3136 is less than 64k. And if I divide both sides by 64, then I get 49 is less than k. So now I know that for my discriminant to be less than 0, my k value needs to be greater than 49. Another way of saying 49 is less than k is that k is greater than 49. So for this discriminant to be less than 0, and for there to be no real solutions, k needs to be greater than 49. So it could be any value greater than 49. It could be 50, it could be 100, it could be 1000. It just needs to be greater than 49. But they're asking for the least possible value of k, and they told us that k is an integer, which means that it has to be a whole number. So then the least possible value, the least possible integer that's greater than 49 is 50, right? So then k must be equal to 50. So that question dealt with the discriminant. This question says one solution to the given equation can be written as 1 plus square root of k, where k is a constant. What is the value of k? So this question is going to deal with the quadratic equation. So you should review that if you missed this question. We know that the quadratic equation is x equals negative b plus or minus the square root of b squared minus 4ac over 2a. And the thing about the quadratic equation is that it usually gives you something in this form. Its solutions usually involve some number plus a square root or minus a square root. So whenever you see some solution that's in this form, you should be thinking of the quadratic equation. It could be in play. So now if we plug in our a, b, and c values, we can see that our a value is just 1, the x squared coefficient is 1, b value is negative 2, c value is negative 9. If I plug those into here, I get 2 plus or minus the square root of negative 2 squared, which is 4, minus 4 times 1 times negative 9, all over 2 times 1. And now if I solve this, I get 2 plus or minus the square root of 4 plus 36 over 2. 2 plus or minus square root of 40 over 2. Now, if I divide both of these by 2, I get 1 plus or minus square root 40 over 2. Now, the thing is that they're not asking for, or they're not giving the answer choice in the form of this here. They're giving it to us as 1 plus or minus k, right? 1 plus or minus root k. So in other words, this term here needs to be just one square root. It can't be root 40 over 2. So we need to find out a way, how can we manipulate this into just one square root? So I'm going to rewrite root 40 over 2 as 1/2 root 40. And now one thing I can do is, instead of writing 1 over 2 as a whole number like this, I can actually write this as, it's not a whole number, but instead of writing it like that, I can write this as square root 1/4, because square root of 1/4 is 1/2, right? So I'm allowed to do that. So square root 1/4 times square root 40, and you're actually allowed to combine square roots if they're multiplying by each other. So this is going to become 1 plus or minus the square root of 1/4 times 40. So 1/4 times 40 is 10. So I have 1 plus or minus 10, and my solutions are 1 plus root 10, 1 minus root 10. So my k value is going to be whatever is inside the square root, which we know is 10. So that's going to be the solution. Okay, this next problem says, in the given equation, p is a positive constant. The sum of the solutions to the equation is 20 over 3. What is the value of p? So we can see that we have three factors, right? We have 3x plus p times 5x squared minus 45 times 2x squared minus 16x plus 6p. So we can see that when we have three factors that are multiplying by each other and that set equal to 0, if either one of these factors is 0, then if any one of these factors is 0, then the entire thing becomes 0, right? So if this was 0, then 0 times all of this becomes 0 and the equation is true. Same thing if this factor is 0 or if this factor is 0. So the solutions to these equations are the x and p values that make each factor equal to 0. It's saying that the sum of these solutions is 20 over 3. What is the value of p? So what we need to do is set each one of these equations equal, or set each one of these expressions equal to 0, and then solve for p, I guess. So let's start with this first one. 3x plus p. 3x plus p equals 0. So then the solution is 3x equals negative p. X is equal to negative p over 3. So that's our first one. That's our first solution. Now, second solution, 5x squared minus 45 equals 0. So 5x squared equals 45. X squared equals 9. If you take the square root of both sides, you get x is equal to plus or minus the square root of 9, which is plus or minus 3. So then those are our next two solutions. And then finally we have 2x squared minus 16x plus 6p equals 0. So why don't we go ahead and factor 2 from all these terms, and we get x squared minus 8x plus 3p equals 0. So let's see here. We can go ahead and solve, because I don't really want to solve this using factoring. I don't know if that's possible. We're going to go ahead and solve this using the quadratic formula. First, I'm going to go ahead and just get rid of this 2 by dividing both sides by 2, and I get x squared minus 8x plus 3p equals 0. So now I'm going to plug this into the quadratic formula, and if we do that, we get x is equal to 8 plus or minus the square root of 64 minus 4 times 1 times 3p. Remember that our c value here is just going to be 3p. And then this is all divided by 2 times 1, or 2. So x equals 8 plus or minus 64, the square root of 64 minus 12p. Let's see, yeah, that's correct, over 2. So these are our other two solutions, I guess. So our solutions now are negative p over 3, plus or minus 3, and all of that. So what we can do now is we can go ahead and add them all up, because we know that the sum of these solutions, if we add them all up, is 20 over 3. So my first solution is negative p over 3. Second two solutions are plus or minus 3, so I can just say plus 3 minus 3. And then third two solutions are, let's see, we can say plus 8 plus root 64 minus 12p over 2, and then plus 8 minus, because this thing is a plus or minus, so 8 minus root 64 minus 12p over 2. So now if we add up all of these solutions here, right, all these are solutions to our equation. If we add them all up, then that should equal 20 over 3 based on what they've given us. So let's see if we can add these up. We know that these plus 3 minus 3 just cancel out, right? And then over here, we can actually go ahead and add these two fractions, right? So if we add these two fractions, because it's easy for us since they already have this common denominator. So this is going to be 8 plus root 64 minus 12p, and then plus 8 minus root 64 minus 12p all over 2. So now this actually becomes easy because the root 64 minus 12p minus root 64 minus 12p is 0, and this just becomes negative p over 3 plus 8 plus 8 is 16 over 2 is equal to 20 over 3. So now it becomes much easier. We've gotten rid of the difficult stuff, and we have negative p over 3, and then plus 8 is equal to 20 over 3. Now if we subtract 8 from both sides, we get negative p over 3 equals 20 over 3 minus 24 over 3. This is just 8 written as a fraction. So now we have negative p over 3 equals negative 4 over 3, and we can see that p is just going to be 4. So then that's our answer. Let's go to the next problem. It says in the given system of equations, h is a constant. If the system has no solution, what is the value of h? So this is another system of linear equations problem, and we know that for a system of linear equations to have no solution, the two lines need to be parallel. So what I'm going to do is first rewrite both of these equations in slope-intercept form, and then just set their slopes equal to each other, because we know that parallel lines have the same slope and different y-intercepts. So let's start with this first equation. We have 4x minus 9y equals 9y plus 5. So I'm going to rewrite this in slope-intercept form. So I'm going to move all of my y's to the left side and all of my x, or why don't I move all of my y's to the right side for now and all my other terms to the left side. So I end up with 4x minus 5 equals 18y. And now I'm just going to divide both sides by 18. So I get y is equal to 4 over 18x minus 5 over 18. So that's the first equation converted to slope-intercept form. Second equation, hy is equal to 2 plus 4x. This one is already almost in slope-intercept form. All I need to do to convert it is divide both sides by h, and I get y is equal to 4 over h x plus 2 over h. So we can see that the slope in this case is 4 over h, and the slope in this case is 4 over 18, right? So if we want these two slopes to be equal, h just needs to be 18. And we know that if the slopes are equal but the y-intercepts are different, then the lines are going to be parallel and there's going to be no solution. So our answer here is going to be 8. Okay, this next question says, which of the following expressions is or are a factor of 3x squared plus 20x minus 63? So if we take a look at this, why don't we start off by, why don't we go ahead and factor this, right? We have 3x squared plus 20x minus 63. Let's see, actually, it might be a little bit difficult to factor this. We'll actually skip this question for now because it has to deal with dividing polynomials and we haven't gotten to that yet. So we'll come back to this question later. Let's look at this one. It says a cube has a volume of 474,552 cubic units. What is the surface area in square units of the cube? So remember that the surface area of a cube is just, you have this cube. Remember that it has 6 faces, and you're just adding up the area of each of these faces. The surface area is different from the volume. You just take each face of a cube and you find its area and you add that up, right? So we know that its volume is this, right? And we know that for a cube, the length, width, and height are all the same, right? Because it's a cube, right? It's made up of squares. This length is the same as this length, which is the same as the height, right? So length times width times height, which is the area for a volume of a cube, is equal to 47,452. And we know that length, width, and height are all the same amount, right? Because it's a cube. So I can just replace this with s times s times s, where s is a side length. So in other words, s cubed is equal to this number. And now all I need to do to find s is take the cube root of both sides. So I get s is equal to the cube root of this number. So now let me go ahead and find the cube root of that number. So the cube root of this number is going to be 78. So now we know that the side length is going to be 78. And if we want the surface area, we just need to find, again, you take each face of the cube, you find its area, and you add it up. So the area of one face of the cube is just side times side, right? Or 78 times 78. And the area of all 6 faces is just do that 6 times. So I'm going to multiply that by 6. So I have 78 times 78 times 6. Let's see what that gives me. That's going to give me 36,504. So then the surface area is 36,504 square units. So then that's my answer. That's the surface area. This next question says, for the function q, the value of q of x decreases by 45% for every increase in the value of x by 1. If q of 0 is equal to 14, which equation defines q? So again, this is another problem dealing with exponential equations. So it's saying that it decreases by 45% for every increase in the value of x by 1. So that means that this is going to be dealing with exponential decay. Remember that with exponential decay, your growth factor should be less than 1, right? So we know that growth factor can't be 14, right? Remember that exponential equation is written in the form a times b to the power of x, where b is your growth factor. So our growth factor can't be greater than 1. So that means that it can't be this, because it can't be 14. It can't be 14. It could be C, and it can't be D because it can't be 1.45. If you multiply a number by 1.45, that's going to increase it, right? So it can't be that, so it must be this. And another way that you can tell that the growth factor is going to be 0.55 is that, notice how it says that the value of q of x decreases by 45%, right? So if a number starts off at 100% and you take away 45%, you're going to be left with 55% of it, right? So that's why we're multiplying by 55% or 0.55, because we're decreasing by 45%, so what's left is 55%. And we can see that q of 0 is equal to 14, so the initial amount is 14, which also checks out. So then C is our answer. This next question says a function f is defined by f of x is equal to x minus 6 times x minus 2 times x plus 6. In the xy plane, the graph of y equals g of x is a result of translating the graph of y equals f of x up 4 units. What is the value of g of 0? So if we want to do this translation, remember that, so this is f of x, right? And remember that in outside translation, or a translation that affects y, all we need to do is add 4 on the outside. So if we add 4 on the outside, this is now g of x. That's all you need to do. And it's asking for the value of g of 0, so we just plug in 0. So 0 minus 6 is negative 6, 0 minus 2 is negative 2, 0 plus 6 is 6, and then plus 4. So now we have negative 6 times negative 2 times 6 plus 4. Let's see, what is that going to be? 12 times 6 is 72, plus 4 is 76. So g of 0 is going to be 76. So if you got this question wrong, then you should review transformations of functions